vectors finding their magnitude and direction. Here we have a vector, here's its initial point, and here where the arrow is, that's its terminal point. And the vector can be called as labeled P to Q here. It could be P, Q with an arrow over it indicating it's a vector. Or you see this U right here. You could also label it as a bold-faced U with an arrow. So I'm going to start here with this vector right here, U. And so I'm just going to say the vector U. First of all, its initial point we can see is at the origin, it's at 0, 0, and its terminal point is at -3, 2, that's where it ends, right there. So then we're going to use the distance formula to find the magnitude of U, so use this notation, and it's going to equal, using the distance formula, difference of the x's, so -3 minus 0 squared, difference of the y's, 2 minus 0 squared, and what you end up getting is root 13. So that's the magnitude for the vector U. And then for so you have watched the lesson for 9.2b, which is more on vectors and more about the direction of vectors and measuring the angle. Yes. Now you're going to be working on the problem set for lesson 9.2b. So I'm going to come around and just check. I see most people had it done by the end of class. Now I'm just going to check anyone who I'm missing. And I have a couple hints and clues up here. Specifically about vectors, tail-to-tail vectors, you want to use parallelogram. Tip-to-tail vectors, you want to use a triangle. And then problems in the problem set 35 through 38. Many people in the last class were making mistakes about the alpha angle. This will make more sense once you get to those problems. But obviously, as you have questions, I can come and help you answer them. So take out lesson 9.2b just to verify that you have it done, and you can get started on the problem set. What?
It's cute that.
Are we on 26 now?
It's like Coyote Hall.
Oh, you're right. Q to x. What is that? Yes?
-1.
-1, 0. How do you know that? Oh, when you move the pieces down, that's what you got. Okay, so now you know the end. So can we show this to him too? So you know Q, and you know, can we call that x?
Yeah.
So you know Q to x is going to be the distance formula between those 2 points, which you discover what that point is. Explain to Dan how you figure out what that point is.
Damn, dude. Well, then you can say it. So it equals 60. It equals. That's cute.
How do you know?
61.
Yeah.
Wait, it's a toy.
85.
Root 61.
So it equals just root 65.
Yeah, but it has to be
Yeah. And that's answer 0.1.
You don't know what 5 is. Wait, it's 1 on my side, just squared plus. What'd you get? What'd you get?
16.
Root 61. Root 10. Is that right? Yep. Yes.
Yeah.
So then you make this one.
So if I'm asked to find the magnitude of SQ plus SR, and
Okay.
SQ is from here to here, and
Yep.
SR is from there to there.
Yep.
And I make my parallelogram, am I trying to find SX?
Yes. And what is that called again? From S to X?
The resultant.
The resultant.
But-
But the way I described it to these guys,
Yeah.
Sam, will you be part of this for a second?
Yeah, what's up?
Will you pull her arm that way? No, no, no. You, Sam, pull her arm that way, and I'll pull your arm this way. If we continue pulling her that way and this way, where's she gonna end up actually going?
In between?
In between there, right? So there's your result.
Okay.
Does that make sense?
Yeah, but how do I find where X coordinate is?
Okay, so that's a great question. You have to go and figure out, can we maybe draw that again a little bigger and a little clearer, easier to see?
2, 0, and
I understand it's a small parallelogram, but if you make it bigger, we can maybe see it a little better. And let's label what those points were. So back from the question.
S is 5'9".
Yeah.
What's Q again? I think it's Q is 4'6".
Good.
So F is
4, 6. Okay. There we go. Okay.
2 forces.
And then
R
draw, what was the other
is
point?
4
Or 4, 3.
What is R?
Let's look back.
R is 4'3".
Yeah, I knew that.
Yeah.
Well.
What?
Okay, so I'm going this way and then I'm also going this way.
Yes, excellent. Okay, so now we want to figure out what this last point is.
Right.
So draw it in as though we know it, and let's work with what we like. Yeah, it looks like it would be roughly there. Yep.
Here.
So the point you're going to find.
Okay, so we already know it's x value is going to be the same as that one, right? Because isn't it on the same line?
Right.
So we can write that in.
So we gotta make a parallel.
And then we say, okay, so how far did we have to go to get from here? Because now we have to find the y value.
Right,
From here to that one. So we went from 6 down to 3, right? So then what must that be?
0.
No, you're going to start at 6 and go down 3. Oh, and then down 3 from there. So you're right, it is 0.
0.
Yep.
Okay.
Good job.
Okay, perfect. So
Does that make sense of how we find
the
that?
axis like that.
Yeah.
Okay, gotcha. Okay, thank
Good.
you. That makes sense.
Okay, so now last step, what is it?
Well, I'm trying to find s to x.
Wait, so
So I use the distance formula from 5, 9, and 4, and 0. Perfect. Okay, thank you.
Nice job.
I knew it. I was
6
just
squared.
To answer Keegan's question, no, you cannot use, we don't know what this point is.
Why not? Haha.
Okay.
See.
So we are correct in saying we need to use law cosines. Good job.
Hey.
So I'm going to call this guy C right here, okay? Law of cosines is, and correct me if I'm wrong, C squared equals A squared
Yes.
plus B squared
Yes.
minus 2AB times cosine of C.
That's what
Yep.
Everyone's okay with that? C squared. Guys, do we know this angle right here?
Yeah, we do.
What is that?
120 degrees.
Okay, how do you know that?
Because
Because
all the some of the angles is
360.
360, so then you subtract.
Can't you just
Subtract 60 twice
and then divide by 2?
Exactly.
Guys, do we know this black dotted line?
Yes.
What is its force?
10.
And how do you know that?
Because it's the exact replica of the opposite.
are.
It's exactly the same as its opposite. Pause for a moment. Everybody, please take a moment to listen to this. It's a silly error, I just don't want you making it. People want to combine this first. Does the order of operations allow for that? No. Do not combine this first.
Wait. Yeah, positive, huh?
Cosine 120 is negative.
Figure out what this is first. Can you please do 160 times cosine of 120?